Hello, hi everyone. So today we are going to solve another Leetcode daily challenge problem. Let's look at what's the daily challenge for today is. As you can see, the title for this challenge is delete node in a linked list. The problem number is 237. The difficulty level is medium, and there are some constraints related to it, and there is a long description, so we'll read it out, try to understand the question, talk about the time complexity and space complexity. So let's get started. There is a singly linked list head, and we want to delete a node in it. So we want to delete a node, right? That's simple. Okay, you are given a node to be deleted node. You will not be given access to the first node of head. Oh, okay. So this makes the problem a bit challenging. So the access to the head is not given, but we have to delete a node. All the values of the linked list are unique. Mhm. And it is guaranteed that the node is not the last node in the linked list. Okay, so this is kind of constraint which is written in the description as well. So we'll look at it. Yeah, I can see that it's here. Value of each node in the list is unique, and node to be deleted in the list and is not a tail node. So that's the same thing. Delete the given node. Note that by deleting the node, we do not mean removing it from memory. Okay, we mean the value of the given node should not exist in the linked list. Correct. The number of nodes in the linked list should decrease by one. Correct. All the values before node should be in the same order, and all the values after node should be in the same order. Yeah, makes sense. Custom testing. So if you are like using this console and then like using your own test cases for that purpose, I believe this is the instruction given here. For the input, you should provide the entire linked list head and the node to be given node should not be the last node of the list and should be actual node in the list. Okay, and we will build the linked list, pass the node to a function, output will be. So if you are writing your own test case, in that particular case these instructions should be helpful. So let's look at the example and see like what and how it's being done. We can also see the solution tab is open, and we can take a hint from there if we are stuck. Let's look at the example. So the linked list is the head is 4519 and the node that needs to be deleted is 5. So after deleting, the output should be 419. You are given a second node with value 5. The linked list should now become 419 after calling your function. So in the test case, this is how it looks. But when we are solving this delete node method, what exactly happens is we are just given the node. Node is a type of list node, and this needs to be deleted from the linked list. And by deleting, these four criteria must satisfy. That means should not exist in the linked list. The size of the linked list should be decreased by one, and before and after removing the nodes, I mean before and after the nodes, the order should be same for all the values. Similarly, for another questions 4519, if the node value is 1, then after removing it, the linked list is decreased by 1. The order is preserved before 45, after 9, and it's linked like this. Interesting. And if we look at the constraints, the number of nodes in the given list is in the range 2 to 1000. Okay. And the node values are given, the value of each node is unique, and the node to be deleted is in the list and is not a tail node. So these are the constraints and was a part of description as well. This is quite interesting because if we have a pointer to head. That means here it's clearly written you are not given the node to be deleted. You are given node to be deleted node. You will not be given access to the first node of head. So if we are not given the first node of head, how we are going to determine uh, the deletion has taken place? Hmm, this is a bit difficult for me, and I see the number of submission versus the number of accepted. It's quite high, and maybe because the solution tab is open and we are free to use that, right? So let's take a moment to think how it can be done. Okay, so it might take much time for me to come up with an solution how to figure this out. And since this is a recording and I do not want to lengthen this recording for lengthen this recording, so what I'll do is I'll just take a help of the solution tab and we'll try to code it based on the description. We'll not look at the code exactly how it's being done in the solution tab, and then let's see. So this is my first video ever where I am using the solution from the solution tab. Okay, so let's read this as well. The problem is, oh, this is just the overview, and here's the first approach. Is there any second approach? Nope. So yeah, there is only one approach. Delete next node instead of current one. Okay. And what is the intention behind it? To solve the problem, let's look at the condition carefully. It is guaranteed that the node to be deleted is not a tail node, right? There are few observations here. The conventional deletion approach will fail here since we are not able to get the previous node by iterating from the head of the linked list. That's true. In fact, we do not have any method to fetch the previous node because it's a single linked list. We do not know like what was the previous node, right? Without the knowledge of the previous node, it is not possible to delete the current node. That's true. That is where we were stuck. Notice that we are told that given node is not a tail node. Therefore, we can delete the next node instead of current node given and pretend that the node we are given is the next node. Ah, very smart. Using this function, let's understand how to implement this problem. So just by understanding, I have a rough idea on how to approach this. But since we are already here, let's look at the algorithm as well, and then we'll do that. Using the using this intuition, let's understand how to implement this problem algorithm. By analyzing the above two key observation, we can derive the following algorithm. So store the next node in temporary value variable, right? Copy the data of the next node to the current node, right? Change the pointer of the current node to the next pointer of the next node. Change the next pointer of the current node to the next pointer of the next node. And note above three steps, make sure that your current node becomes the same as next node, and then you can safely delete the next node from the linked list. But do we have to delete the node from the linked list? As per the description, uh, deleting the node, we do not mean removing it from memory. So we can skip this, but for like if you want, you can delete it. So I'll just skip this whole thing. Initial linked list is this. Update the current node with node details. So whatever the next node is, update with the next uh, update the current node with the next node details. So yep. And now what happens is update the current node next pointer to the next node next pointer. So we'll skip this one. That means the order is preserved and the node is being deleted. And the power here is because of these two constraint, I guess. Yeah, the the value of each node in the list is unique. I mean, even if it was not unique, uh, no, it must be unique. Otherwise, like we would not know what exactly. Well, that's fair. We can still do that. Yeah, we can still do that. So technically, this is the only property that helps us, okay, come up with this solution. Is not a tail node. The node that to be needs to be deleted is not a tail node. And there is a solution for it, but we'll not look at it. And the time complexity and space complexity, we already have an answer for this. Big of 1, and space complexity big of 1. So let's try to solve it. Okay, and then we'll see. Store the next node in a temporary variable. Okay, so we'll say that next node is equal to node dot next, right? Copy the data from next node to the current node. So node dot value equals to next node dot value, right? Change the next pointer of the current node. That means node dot next to the next pointer of the next node. That means next node dot next. Yep, that's 3 lines, just 3 lines. And regarding the delete, we'll I'll skip that, but we can delete that as well. Let's try to run this code. If I have an error, I'll we don't have an error. That means a deletion is not required. Yeah, all the example test cases passes. I'll try to submit this. Yep, it works. And we have a completion streak of 4 days. Yay! And that was pretty simple. I could not come up with the solution. Okay, it happens. I mean, that's how we learn, right? So it was an interesting problem. I hope you guys will love it as well while doing this. And please do share some suggestion regarding the video. Please comment, and I'll try to read out all the comments. Also, use that when I'm making the next video, the suggestions which I receive. So अब नेपालीमा हेरौँ है त. सो नेपालीमा भन्दाखेरि आजको डेली च्यालेन्ज के रहेको छ भनेपछि डिलिट नोड इन अ लिङ्क लिस्ट. यसको चाहिँ प्रब्लम नम्बर 237 हो. डिफिकल्टी लेभल चाहिँ मिडियम छ. अनि यो क्वेसनले चाहिँ के भन्दैछ भनेपछि एउटा सिङ्गली लिङ्क लिस्ट छ हेड भन्ने. अनि हामीले चाहिँ त्यो सिङ्गली लिङ्क लिस्टबाट चाहिँ एउटा नोड डिलिट गर्नुपर्ने. त्यो नोड डिलिट गर्दाखेरि चाहिँ हामीलाई हेडको एक्सेस चाहिँ दिएको छैन. सो हेड नोड चाहिँ के छ भनेर हामीलाई थाहा छैन, तर नोड चाहिँ डिलिट गर्नुपर्ने. अनि अल द भ्याल्युज इन द लिस्ट चाहिँ जतिवटा भ्याल्युहरू छ नि नोडहरूको सबै युनिक छ. र जुन डिलिट गर्न लागेको नोड छ त्यो चाहिँ जुन जुन नोड चाहिँ डिलिट गर्नुपर्ने त्यो चाहिँ लास्ट अथवा टेल नोड चाहिँ छैन भनेर, नट द लास्ट नोड है. अब डिलिट भनेको के हो त? डिलिट भनेको लाइक मेमोरीबाट रिमुभ गर्ने होइन. त्यसपछि डिलिट गर्दाखेरि चाहिँ त्यो जुन डिलिट गर्नको लागिरहेको छ नोड त्यो चाहिँ लिङ्क लिस्टमा हुनै पर्यो. अनि लिङ्क लिस्टको साइज डिलिट गरिसकेपछि 1ले डिक्रिज हुनु पर्यो. र त्यो नोड भ्याल्युभन्दा अगाडिको जति भ्याल्युजहरू छ सेम अर्डरमा आउनु पर्यो, पछाडिको जति भ्याल्यु छ सेम अर्डरमा आउनु पर्यो है त. अनि यहाँ अलिकति इन्स्ट्रक्सन कस्टम टेस्टिङको लागि छ. सो इन केस हामीलाई चाहिँ आफ्नो टेस्ट केसेसहरू क्रिएट गरेर यहाँ टेस्ट गर्नुपर्ने छ भनेपछि हामीले यो इन्स्ट्रक्सन फलो गर्नुपर्छ है त. अनि इक्जाम्पलमा हेर्दाखेरि 4519 भन्ने चाहिँ एउटा लिङ्क लिस्ट छ विच इज ओन्ली रेस्ट्रिक्टेड टु इक्जाम्पललाई देखाउनलाई मात्र हो. हामीले चाहिँ 5 भनेर मात्र पाउँछौँ नोड. यो 5 लाई चाहिँ डिलिट गर्नुपर्ने। सो यो 5 डिलिट गर्दाखेरि ओरिजिनल जुन लिङ्क लिस्ट छ त्यो चाहिँ के हुन्छ 419 हुन्छ अब, किनभने चाहिँ त्योभन्दा अगाडिको जति थियो क्यारेक्टर्स सरी नोट्स त्यसको चाहिँ अर्डर प्रिजर्भ छ र भ्याल्युहरू सिमिलरली पछाडिको नि प्रिजर्भ छ र साइज चाहिँ हाम्रो के छ 1ले डिक्रिज भएको छ है त। सिमिलरली 4519 छ भनेपछि 1 चाहिँ डिलिट हुने भयो, 459 चाहिँ यसरी कनेक्ट हुने भयो। यो चाहिँ लिङ्क लिस्टको पार्ट हुन्छ अब। सो यो क्वेसन सल्भ गर्दाखेरि चाहिँ म अड्केँ, अनि कसरी गर्ने होला, किनभने चाहिँ हेड नोड चाहिँ थाहा भएको भए वी कुड ह्याभ सिम्पली हामी चाहिँ लाइक आइट्रेट गरेर त्यो नोडसम्म जान्थ्यौँ जुन नोड डिलिट गर्नुपर्ने, अनि त्यसपछि चाहिँ प्रिभियस नोड हामीलाई थाहा हुन्थ्यो, करेन्ट नोड थाहा हुन्थ्यो। सो प्रिभियस नोडलाई चाहिँ हामीले नेक्स्ट नोडसँग करेन्ट नोडको नेक्स्टसँग कनेक्ट गरिदिन्थ्यौँ अनि द्याट्स हाउ डन। तर हामीलाई हेड नै थाहा छैन, हेड नै थाहा छैन कहाँ छ भनेपछि कसरी गर्ने भनेर थाहा भएन। सो मैले चाहिँ यहाँ सल्युसन ट्याबको चाहिँ युज गरेँ र यो सल्युसन ट्याबमा चाहिँ अलिकति आफै पढ्नु होला। यसमा चाहिँ अप्रोच चाहिँ फर्स्ट एउटा मात्रै अप्रोच छ, डिलिट नेक्स्ट नोड इन्स्टेड अफ करेन्ट वान। र अल्गोरिदम हेर्दाखेरि चाहिँ इट्स प्रिटी सिम्पल। र अल्गोरिदम के छ भनेपछि नेक्स्ट नोडको जुन भ्याल्यु छ त्यसलाई चाहिँ पहिला टेम्परेरी भेरिएबलमा स्टोर गर्ने, त्यसपछि चाहिँ नेक्स्ट नोडको जुन भ्याल्यु छ डेटा, भ्याल्यु एज इन डेटा, त्यो चाहिँ करेन्ट नोडमा स्टोर गर्ने, अनि करेन्ट नोडको जुन पोइन्टर छ त्यो नेक्स्ट नोडको नेक्स्ट पोइन्टरमा कनेक्ट गर्ने। सो यो तिनवटा लाइन नेक्स्ट नोडलाई चाहिँ पहिला हामी नोड डट नेक्स्टबाट चाहिँ टेम्परेरी भेरिएबलमा राख्यौँ, त्यसपछि करेन्ट नोड जुन छ त्यसको भ्याल्युलाई चाहिँ हामीले नेक्स्ट नोडको भ्याल्युसँग अपडेट गरिदियौँ, अनि त्यसपछि करेन्ट नोडको नेक्स्ट जुन छ त्यसलाई चाहिँ हामीले नेक्स्ट नोडको नेक्स्टसँग कनेक्ट गरिदियौँ। सो यसरी गर्दाखेरि चाहिँ हाम्रो सबै इक्जाम्पल टेस्ट केसेसहरू पास भयो र इन्क्लुडिङ हाम्रो सबमिट गर्दाखेरि चाहिँ लिडकोडमा भएको टेस्ट केसेसहरू। सो या यति नै हो। र यसको टाइम कम्प्लेक्सिटी र स्पेस कम्प्लेक्सिटी यो सोल्युसन ट्याबमै पहिले भनिसकेको छ, और बिग अफ 1, किनभने चाहिँ हामीले एउटा टेम्परेरी भेरिएबल मात्रै युज गरिरहेको छौँ र सिम्पली एक्सेस मात्र गरिरहेको छौँ है त। सो एक्सेसिङको लागि चाहिँ लिङ्क लिस्टमा बिग अफ 1 छ। सो सिन्स only one needs to be updated, I'm only traverse one node behind, right? अनि स्पेस कम्प्लेक्सिटी पनि बिग अफ 1 बिकज वी आर युजिङ हामीले चाहिँ एउटा कन्सटेन्ट एक्स्ट्रा स्पेस मात्र लिइरहेछौँ नेक्स्ट नोडलाई ट्र्याक गर्न। सो आजलाई यति नै। केही सल्लाह सुझाव छ भने कमेन्टमा छोड्नु होला। धेरै धेरै धन्यवाद यो भिडियो हेरिदिनु भएकोमा, र यो भिडियो मन पऱ्यो प्लिज लाइक, सेयर एन्ड सब्सक्राइब। थ्याङ्क यू सो मच, ह्याभ अ गुड टाइम, बाई।